Hey everybody, Mr. Kolu here, back with a little more Kolu math. And today we're going to be talking about a tool you might be familiar with from your math class. It's what we call a number line. And a number line is a tool that's used to visualize value in simple operations. That's another one of those definitions with words that don't really kind of tell you what's going on. You have to sort of think about what they mean. Let's simplify that a bit. So you can think of a number line as a tool that is used to show you the size of numbers, value, right? And what plus, minus, multiply, and divide look like, simple operations. Today, we're only going to be talking about plus and minus, but in a future video, we might be talking about multiplying and dividing with the number line as well. So, what exactly is this thing? Well, first we'll start with a line. And guys, you know that that's not really a line. That's actually a line segment. And how do I know it's a line segment? Because it ends. Lines are actually concepts. Lines actually go on forever. So the end of that line you see going to the left, that just keeps going right past the edge of your screen and goes straight to the sun and through it and across the universe. It's an idea. It goes on forever. That's because numbers just keep getting bigger. In fact, the amount of numbers, the amount of integers we have is infinite, right? Think of the biggest number you can think of and then add 1 to it. You can always do that. So that's what infinite is. And lines are infinite. They go on forever. So is our number line. Got a little off topic there. You know me in math. Okay. So we put some markings to delineate some metering on this line here, and we center it around 0. Now, our number line doesn't always have to be centered around 0. We're just going to be using that for today's examples. Okay, next I'm going to add some numbers, some integers to the right side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm going to do the same to the left side. Okay, don't freak out. All right. Listen, let's not even worry about that for the time being. I mean, it's an important part of the number line, but I don't want to scare anybody. All right, so take a look at that number line. What does it remind you of? Well, if you're anything like me, it reminds me of a ruler. And in fact, that's exactly how it works. The same way we might take an object and measure it against a ruler and find out its length, a number line works pretty much the same way. So in this case, a number, like 3, we know where to place that on the line because of the scale. Now, 3 is a little different than that worm up there because 3 already tells you how long he is. It'd be kind of like if the worm was wearing some identification about his length. But that doesn't mean that the number line's not useful. The number line's really good at sorting information. So if you have a bunch of different numbers, you can place them on a number line, and now we can start telling things about relative value, how big they are. We know that 9 is larger than 3, and we can also see that 7 is larger than 5. And that shows us one of the first rules of the number line. And every number line works the same way, that as you go to the right, the numbers get bigger, and as you go to the left, the numbers get smaller. And that's the first function of the number line, to show you value, the size of numbers. All right, well, let's take a look at an example where the number line demonstrates simple operations for us. Okay, Jimmy has 4 tacos, Sarah has 3. How many tacos are there total? Very simple problem. And let's look at it first kind of in the way we learned how to do addition and subtraction, with what I call the counting method. So we start with Jimmy has 4 tacos, 1, 2, 3, 4. Sarah has 3 tacos, 1, 2, 3. How many do they have together? Well, we just count the whole amount, 1, 2, 3, 4, 5, 6, 7. And that tells us they have 7 total tacos. Now the number line does the same thing, but just in a different way. See, the number line can start at 0. We add Jimmy's tacos, 1, 2, 3, 4. And then we can add Sarah's tacos, 1, 2, 3. All right, and you can see the pointer, in this case the little taco there, ended up on the number 7, which is our answer. Let's take a look at another example. Okay, if they eat 5 tacos, how many do they have left? Let's do it first with the counting method. We see we have 7 tacos up there. Let's count out 5 of them, take them away, and how many do we have left? 1, 2. We have 2 tacos left. The number line again can do the same kind of thing. Take a look. The number line already has the pointer, the taco at 7, because we've represented Jimmy's tacos and Sarah's tacos. Now all we have to do is take away 5, and we do that by moving the pointer back 5 spaces. 1, 2, 3, 4, 5. Okay. So if we go back to thinking about the rules that we came up with before, we're still pretty darn certain that as you go to the right, numbers get bigger. As you go to the left, numbers get smaller. It also seems like if we add numbers, the pointer moves to the right. And if we subtract numbers, the pointer moves to the left. Huh. Well, let's keep looking and see how things turn out. All right, here, let's bring up kind of a simple example. We've got 3 plus 5. And if we work it the same way, we know that 3, 1, 2, 3, plus 5, 1, 2, 3, 4, 5, equals 8. And it's just that simple. Now, you might be wondering, why do we have plus 3 there? There's no plus in front of that 3. Well, actually, there is. It's a positive 3. There's always a plus in front of it when we think about combining variables and different sort of objects. An x without anything in front of it is positive. It's a plus x. All right, cool. Let's move on to another example. So we've got 9 minus 8. So same deal. We'll count out 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll take away 8 by moving the pointer back 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. And that leaves us with 1. Not too bad. Okay, maybe we're getting kind of comfortable with these things.
Excuse me, sir.
Oh, hey, Joe. I haven't seen you in a while. I thought maybe you were in a different class.
No, same class. See, this is a waste of time, Mr. Kolu, because I could have done this on my fingers. I could have just said, well, I've got 9 fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll take away 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And I'm left with 1 finger. So why am I wasting all this time with the number line? Is this another one of these things that the math teachers waste our times with?
Joe, I promise you a math teacher would almost never, ever waste your time. I mean, well, some of them. But not yours, okay? You're right, Joe. You just did a great job there demonstrating the counting method. The number line actually demonstrates its value with a question that's, a little different than this one. Let's take a look at this one here. We've got 4 minus 6. Joe, why don't you walk us through your thinking?
Okay, well, I've got 1, 2, 3, 4 fingers, and then I'm going to take away 6. Well, I ran out of fingers. It's almost like I'm missing 2 fingers that I needed to count out.
Well, Joe, don't panic. Actually, it can all be solved by what's hiding underneath that under construction sign. In fact, let's get rid of that. Take a look. We've got these negative numbers. Now, they might be scary, but just stick with me here for a moment. Don't even start getting scared. Let's just follow the rules. So we've got 4. 1, 2, 3, 4. And we're going to take away 6. 1, 2, 3, 4, 5, 6. And we can see the answer right there. -2. We don't even need to know anything about negative numbers, and we just calculated a -2 using the number line. Let's take a look at another one. All right, so we count up 3, 1, 2, 3, and we take away 4. 1, 2, 3, 4. Cool, and we end up at -1. See, we don't even have to worry about these negative numbers. Who cares if they're scary? We can just use the number line, and we never have to even think about what they are. Oh. Okay. Well, I guess we're going to have to talk about it. What are we going to do? So, yeah, what is this negative number? What are these things on this half of the number line? Why are they there? What do they do? Okay, you can't have -1 apples. What a waste of time. Well, let's talk about it. But first, it helps if you think of 0 as like a mirror. And you notice that every integer on the right has a pair with an integer on the left. So you've got 5 on one side, -5 on the other. You got 8 on one side, you got -8 on the other. But why? What's all this about? Why am I talking about this? Why am I bothering my poor students with this nonsense? Because it's actually really important, and it comes up in a lot of things. Science and later levels of math. We kind of got to get a grasp of these things, so let's make sure to give it a good college try. Okay, 2 of my friends, Abe and Tommy, they both have a couple dollars to their name, $3 each. I guess that's a few dollars. Okay, and let's actually make a balance sheet just so we can follow what's going on with their money. Now, they're both very smart gentlemen, but Abe has a problem. He has a weakness. Every time he sees that ice cream truck, he's just got to buy himself his favorite ice cream. Okay, if you notice the balance sheet updates, Abe only has $2 and Tom still has 3. Well, guess what happens the next day? The ice cream truck shows up again. Poor old Abe is powerless, buys himself an ice cream, and now he's down to $1. Okay, next day, ice cream truck comes by, and Abe has $1 left. He gives it over to the ice cream man, gets his ice cream bar, and we can see the balance sheet tells us that Abe has $0 but a delicious ice cream, and Tom has $3. Now, where this all gets interesting is what happens on the next day. All right, so the ice cream truck comes just like it always does, but Abe doesn't have any money. So he comes up with a bright idea, and an idea that's been running around here for a couple millennia. He wants a loan, and he asks Thomas to give him $1. Thomas, being a nice friend, says, sure, but you got to pay me back. Great. He gives that dollar over to Abe. Abe gives that money to the ice cream man, and he gets his favorite ice cream. The question is, what's on Abe's balance sheet? What do we call this? And actually, we call it -1. I'll tell you why. So the next time Abe gets his hand on any money, first time $1 comes into his possession, even if the ice cream truck comes by, he can't use that dollar to buy ice cream. Why? Because it's not really his dollar. In fact, he's got to give that dollar to Tommy. What that -1 demonstrates to us is that Abe is in debt, that even when he gets another dollar, he still won't have $1. He'll just be back up to 0. And when Tom gets his money back, he gets 3. Actually, kind of interesting. Most accountants would have said Tom had 3 the whole time, even after he loaned money to Abe, but who knows? We'll talk about that another day sometime. Cool thing about negative numbers are they don't just have to be small here. Sometimes they can be rather large. Well, actually as large as they need to be because of that mirror. They're the same size on both sides. That's probably good thinking there, Tom. Okay, well, let's go back to our example and see if that helped. Nope. No, that didn't help at all. Okay, well, let's think about it. So 5 is 1, 2, 3, 4, 5 over here. And -7 is 1, 2, 3, there. -7. Yeah, I mean, how do you add those two together? That seems weird, right? Well, let's take a look at that earlier example and see if we can make a little more sense out of it. So we took Jimmy's tacos and we put them on the number line, 1, 2, 3, 4. And then we took Sarah's tacos and added it to that, 1, 2, 3. We got to 7. You know, I mean, I have those blocks that say Jimmy's tacos and Sarah's tacos, but they're not like a tangible object, right? I mean, really, all we're doing is moving that taco pointer. So if you think about Sarah's tacos, not so much as 3 tacos, but if you think of it as 3 spaces to the right, it moves that pointer 3 spaces to the right. Well, Jimmy's tacos moves that pointer 4 spaces to the right. Okay, 4 plus 3 gets you 7. So maybe this is a lot easier if we think about the integers as numbers of spaces to move the pointer and what direction they move in. So if we go back to our example here, we can think of 5 spaces to the right, and we know that -7 is 7 spaces to the left. Well, all we've got to do is move 5 spaces to the right, and then we move 7 spaces to the left. That gives us our answer. In this case, -2. So that's maybe even a better way to do this, and we'll try that strategy more going forward. As you guys know, I always like to show you many different ways to think about something, and hopefully one sticks. Okay, let's review what we know so far about the number line. We know that numbers get bigger to the right, smaller to the left. We know that adding moves the pointer to the right, subtracting moves the pointer to the left, and we've also seen that adding a negative moves the pointer to the left. Wonder why that is. And in fact, we can explain it, like most things, with television. Or in this case, video games. Okay, this is one of my favorite kind of video games. It's called an RPG, or a role-playing game. And in this game, your character has a certain amount of HP, health points or hit points. It depends who you ask. And right now, your character has 20 health points. If you notice, that's kind of like a number line, and it works pretty much the same way. So when an enemy comes around and then attacks Joe, it's going to have a negative effect on his health points. We're going to see that actually was a -2 attack, so he's going to lose 2 of his HP. And you see the meter goes down as well. Now Joe might use a healing item, like this taco, and that might return some of his HP. In this case, that's a +1 taco, so he gets +1 to his health points. The enemy may choose to attack with a bigger attack, a more devastating attack, and that might seriously affect Joe's HP. But you guys know Joe. He can take out any enemy with his massive skills. But the question keeps arising to me when I see these numbers pop above their heads. Are we subtracting a positive 99 or are we adding a negative 99? Did that just blow your mind? Well, actually we're doing both because they're the same. And as you get further in mathematics and get more comfortable with algebra, you'll see that a negative and a positive have sort of a relationship that's not all that frightening. Okay, so back to our information sheet here. And that's why these two arrows are pointing in the same direction, because they're essentially the same thing. And actually, I'm going to have to update the definition on this arrow to talk about positive numbers, right? Because we know it's a positive number that moves it to the left. You have to add a negative number to move it to the same direction. So we should also update the guy up here as well, because we're adding positive numbers. Okay, so what do you think? Do you think that subtracting a negative number moves the pointer to the right? Actually, believe it or not, it does. Let's take a look at an example. Okay, so we've got 3 minus a negative 4. And let's actually talk about that minus. What is that thing? Is that a negative sign, or is that a minus, or is it a dash? Well, we actually learned a little bit about him today, didn't we? We saw that an integer 3, a positive 3, would represent a movement of the pointer 3 spaces to the right. And we also saw that a negative 3 would represent a movement of the pointer 3 spaces to the left. So we can think of that negative symbol as changing the direction of the movement. So an integer like 3 represents 3 spaces to the right. If I add a negative symbol in front, it now represents 3 spaces to the left. If I add another negative symbol, it's back to the right. If I add another negative symbol, it's back to the left. And I can just keep doing this forever. The point is, if we think about integers like spaces or movements of the pointer, we can think of a negative sign as just changing that direction. So how does this work with our previous example? Pretty easily. If we remember that 3 is 3 spaces to the right, we're going to subtract 4 spaces to the left. And remember, since a negative symbol changes the direction of the movement, whatever is inside of those parentheses, whatever we're subtracting, can be flipped to the other direction. So that becomes 4 spaces to the right. And now it's a simple problem. 3 spaces to the right, 1, 2, 3, plus 4 spaces to the right, 1, 2, 3, 4, and we get our answer of 7. You know, let's talk about another way to think about it. So here are our friends, and oh man, Abe has just borrowed money from Tom. Tom now has no money. Abe is $3 in the hole. And actually, gladly, their friend Andrew shows up, and he's going to fix things. And he tells Abe he is going to remove his debt. He's going to take away that debt. Okay? Now, how is he going to do that? How does he take away that debt? How does he remove that negative number, get rid of it? The way he does it is by adding $3 into the system and giving that $3 to Abe. So now Abe has the money to pay back Tom, and Abe is out of debt. So in case that went a little too fast for you, think about it again. To take away the negative, we add a positive. To get rid of that debt, to get rid of that negative number, we had to add money to get rid of it. So how does that help us? If we look back at the problem, we've got a negative number and we're subtracting it. So we can use our little memory tool here. To take away a negative, we add a positive. So to take away a negative 4, we add a positive 4. Cool. Now we can go ahead and follow that out in the number line. Now I'm not such a huge fan of this method. I like thinking of the negative symbol as flipping the direction back and forth. But whatever works, let's get through this. Let's get through this homework and move on with life. All right, cool. All right, 2 more examples and I'll cut you guys loose. We've got 1 minus a negative 8. So let's write this out as spaces and directions. So we've got 1 space to the right, and we're going to subtract 8 spaces to the left. Remember that negative sign changes the direction. So we're going to have 1 space to the right and 8 spaces to the right. And we can go ahead and do that with our pointers. Great, and that tells us the solution there is 9. 1 minus a negative 8 is 9. And you can do that with the other method as well. If we're going to remove a negative, we have to add a positive. One last one here. Okay, negative 6 minus a negative 2. Now I know that's scary, that's starting in a different direction, but we can do it with the exact same thought process. Okay, so we've got 6 spaces to the left, a negative 6, and we're going to subtract 2 spaces to the left. We know that negative sign is going to go ahead and flip the direction. It's telling us 2 spaces to the right, so all we have to do is move the pointer 6 spaces to the left, and then move it 2 places to the right. And that gives us negative 4. All right, not too bad. I wish you guys a lot of luck with the number line. If you have any questions, please let me know in the comments, and have yourselves a great day.